Hey, what's up, guys? This is Chung. So today, let's take a look at 517 super washing machine. So this one is a hard one, and this one is kind of tricky to explain. I will try my best to explain my thinking process. And if you guys don't agree, that's fine. That's totally fine because to be honest, this problem is kind of hard to explain. And yeah, you have to somehow like find a way for yourself to prove the correctness of the solution. All right, so you have n super washing machines on a line. Initially, each washing machine has some dresses or not, and for each move, you could choose any machines and pass one dress of each machine to one of its adjacent washing machines at the same time, right? So this is the key point. So which means you can pass one machine to one to the neighbors at the same time. Okay, given like an integer rate representing the number of dresses in each washing machine from left to right, and you need to find the minimum number of moves to make all the washing machine have the same number of dresses. If it's not possible to do it, return -1. So for example, so the first machine has one dress, and second one has zero, third one has five. So the target, right? So first thing first, right? It's easy to calculate the target, right? Basically, if the total cannot be divided by the number of washing machines, then it's -1. Otherwise, so the target for the example one is 2, right? So at the end, so each of the machines should have 2 dresses, and we can make like the answer is 3. Mm, So I think one of the I'll give you another examples here. So let's say we have this uh, 1, and 2. How about this one? So the target is 1, and what's the answer for this like example here? Is 1. So why is that? Because you know since we can choose this range of machines, right? And we move one dress on the left at the same time, so that we can have like 1, 1, 1, 1, 1, and 1, only within one move. So that's the meaning of this one of the any machines, right? So and to solve this problem, I think the a easier way to understand is by using like a dynamic programming. So which means that we start from the first machine. So let's say we have some machines here, right? And we start from the first one, and we have our target. Okay, so and we use the current addresses to minus to subtract the target, and then we'll have like a delta here, right? And if the delta is greater than 0, it means that we need to pass the sum of the closest to the right side. So here we're only considering the right side. I'll explain a little bit why we do that, but here let's assuming whenever the delta is bigger than zeros, we pass this delta to the next machine, right? And and if the delta is negative, that means that we have to borrow some. We have to get this delta number of addresses from the right side. Yeah, and when we pass this number, let's say when the delta is bigger than zeros, we after passing this number of addresses into the next into the I plus one here, right? Let's say we have I here. So we also gonna update the machines. sorry, the addresses in the I+1 machines. Uh, so actually, let me try to code a few lines here so that I can use the code to explain this logic here. So we have length of the machines, right? If the total, then we return -1, right? If this cannot be divided, then we have our target divided by n. So I'm going to use like move, the move that's going to be the move for the current machine, right? And then we have an answer equal to 0. So for like I said, we start from the beginning, and then we end at the n minus 2 because because it, uh, I'll explain why. So the delta is like machines I minus target, right? So that's that. And we have deltas, and then we can just update the machine I+1 with the delta. So it doesn't really matter. So if the delta is greater than 0, then it means that the machine I+1 will get this delta like addresses because the current ice machine will pass this many addresses to the machine I+1. Vice versa. If the delta is negative, then it means that uh, the machine I+1 needs to give this many this many closes distresses to the current one. Okay. So and actually our goal is that after this ice traverse here, the current the machine's I will have exactly the target number of the addresses, so that then in the end here we can just do a maximum of answer dot move dot I, right? And like I said, right? So if the delta, so here we need to handle this separately. If the delta is greater than 0, then what does it mean? It means that we need to also need to give some like closes to the right side. So remember, we already have updated the machines here, so we will just we don't have to worry about the machine state here. All we want to care is that we have a move dot I dot plus dot delta. So why is that? Why we're only adding this move I plus so adding this move I with delta when the delta is a positive. Otherwise, we're gonna do this, right? We're gonna do this I+1 negative delta. So this part, I know it's kind of tricky. So why is that? Because let's say the current one is so there are like two cases, right? So if the delta, let's say if the delta let's say if the delta is negative, we have like a -2 here, right? This is the delta. It means that we need to basically this one, the I+1 will move too close. Will move too close to the to this I here. That's why the move I+1 needs to be added with this 2 here. And about this part, right? Since so let's say when we are at this I+1, since at the beginning this I+1 the move I+1 already has 2. Okay, which means that so we have to move from this current location. We need to move 2 uh, addresses to the left. But if the machine I minus target, if the delta is greater than 0 on this I+1, it also means that we also need to move this some addresses to the right side. That's why we only increase the moves when the delta is greater than 0. Because when the delta is negative, it means that we are only receiving the addresses from the right side, and the current move, the current index that does not do any like you can say that like the current one does not give any addresses out. It only receives the addresses, or it can pass some addresses to the left side. So here's a concrete example. Let's say we have 0, 0, 5, 11. So at the beginning, right? So we have 0 here, and the target we know it's 4. So the delta for 0 is -4, right? So -4 means that the machine will become to -4. Machine I plus 1 will become to -4. And then here, so here we'll also have like a -4, right? So -4 -4 again, it will be -8 here. So here will be 5 minus 8 will be -3. And the move, right? So the move from here is that, hmm, so the move at this location will be 4. At this location will be 8. So actually what you can think is that, at the beginning of each for loop, so if there's any values in the move I here, it represents at the current i's here how many addresses we need to give to the left side, right? So for example here at this location here, right? So we need to give 4 addresses to the left side, and at this location here, we need to give 8 addresses to the left side. And like I said, if the delta at this location is greater than 0 after this calculation, it means that we also need to give some of the addresses to the right side. That's why we only add this move I when the delta is a positive, and then we just get the maximum number out of these things here. So continue, right? So we have 8 here. So at this time, 8 is our answer, and here -3 -3 minus 4 will be what? Will be the delta will be -7, right? So -7 will be passed to machine I plus 1. That's why here will become to 4. So here we'll have 4 in the end, which is the final answer. And another example is like this, right? So we have a 0, 0. Let's say we have a 13 and a 3. So again, right? So we have like, so here we're gonna pass a -4 to this one, right? And here I'm gonna be passing to another -4, total -8. Here we're gonna have 5, right? So, and here we have 4, and when we're at this location, the move will be at the beginning was 8, but then the delta, like the delta is what? The delta is 5 minus 4, and which is 1. 1 is greater than 1. Sorry, 1 is greater than 0. It means that we also need to pass 1 addresses to the right side to make this 3, 4. That's why you mean the moves for this like example is going to be 8 plus 1, going to be 9. Yeah. So yeah, I think that's sorry, I haven't finished the coding yet. Let me finish that. So, and I'm only stopping I'm stopping at n minus 2 because we are going to do a move I plus 1 here or a machine I plus 1. So in the end, we also need to do another like comparison with the last location. The last location is going to be the machines uh, minus 1. That's the last one. Minus target. This is the delta for the last machine. And then we just add it on top of the move minus 1. Yeah, because at the last location, right? Let's say the move I minus 1 equals to the moves we need to move from at the beginning, and this machines these things this delta on top of the moves one will give us the actual movement for the last machine. This is because there's no machines on the right side of the last machine, so that the delta, these things, right, will not be negative because we cannot borrow any addresses from the right, which does not exist. So this delta will always be either 0 or greater than 0. That's why we can just safely add this thing to the moves, to the last move. Okay, so run the code. Okay, submit. Yeah, yeah. So of course it's an often time complexity. Okay, I know this one is hard to understand. I believe my explanation is not that good, but I have already tried my best. I spent a lot of time trying to understand these solutions and trying to find a way to explain this logic uh, in a more intuitive way, but it's still hard. Yeah, cool. Okay, and anyway, thank you so much for watching this video, guys, and stay tuned. See you guys soon. Bye bye.